You are welcome to my YouTube channel. Today I've brought for you the video that students are looking for called balancing chemical equations, and this time I'm using the traditional method or the table method or the hit and trial method, but particularly I'm looking at the table method. Students are demanding for this video. They say we don't know how to balance chemical equations. Remember, I've already posted for a video on how to balance chemical equations using the algebra method or ABCD method. Remember that I told you that there are a number of methods used to balance chemical equations. Number one, we say the traditional method for simple equations. Then we have the algebra method for quite hard equations mixed with simple equations, so it can balance almost all equations if they are not ionic equations, because some ionic equations will have lost some terms, so it can't balance ionic equations effectively. So we have another advanced method for balancing ionic equations called the redox method. I'll present it in one of the videos, but this is for advanced students. Now let's dive into balanced chemical equations by the table method. I've just put some 3 examples for you, but if you follow very well, by the time I finish, you'll be right away to balancing. So this table method actually balances most of the simple equations, but when the equation becomes advanced, it will call for advanced methods such as the algebra method or the redox method. Now let's look at the first equation. Sodium plus oxygen gives us sodium oxide. Now sodium is Na, oxygen is O2, giving us sodium oxide is Na2O2. So the table method we are going to list. Let me remove this lower one first. We are going to look at the atoms on the left hand side and the atoms on the right hand side. So here we have atoms. We have left hand side, we have right hand side. Of course, you can display this method in another way, the way it is convenient for you. So I have sodium here, I have oxygen here. So left hand side I have 1 sodium atom, right hand side I have 2 sodium atoms. Then on the left I have 2 oxygen atoms. Then on the right I have 1 oxygen atom. So it shows that sodium is not balancing, neither oxygen is balancing. So let's start by balancing sodium. Ensure you are using a pencil because it involves rubbing. So we are going to multiply by a suitable number to make it equal to these 2. So I'll multiply this number by 2 to give us a 2 here. So by multiplying by 2, I transfer these 2 direct here. So sodium balances 2, 2. Now let's look at oxygen. Oxygen is O2, so it has 2 oxygen atoms. This way, oxygen is 1 atom, so I have to multiply by 2. By multiplying by 2 here, I transfer this 2 here. Now by transferring a 2, it has made sodium to become 4. So let me multiply by another 2, so there are 4. Then I have to multiply by 2 here to make them 4 this side here. So let's check. Sodium 4, sodium 2 times 2, 4. Oxygen is 2, oxygen is 2. So that's how you balance that equation. Let's look at another example here. So you balance, you can use multiplications. Sometimes you can add just terms on the equation. So let's look at another equation, number 2. Aluminium plus oxygen gives us aluminium oxide. So looking at our table again, of course here are the atoms. Here's the left hand side, then this way the right hand side. So aluminium and oxygen are atoms present, so aluminium is 1, Aluminium, there are 2 on the right hand side, oxygen is 2, oxygen is 3 on the right hand side. So you see that aluminium is not balancing, neither oxygen is balancing. So aluminium can easily be balanced by adjusting a 2 multiplied by a 2, so we transfer this 2 right away up to here. So aluminium balances, but oxygen has a 2 and 3. So if there is a 2 and 3, we can check if we use a number that creates them to have the same LCM. So if I multiply by 2 and multiply this way, so I'm just switching numbers, I'm using a 3 this way, then this 2 I'm using it the other side to check if it will work, because it involves some kind of trial and error. So I multiplied this side, they were 3 oxygens, I multiplied by 2, so transfer that 2 here, they make them 6. Then this way I have to multiply by 3, so I transferred the 3 here. So let me check. So oxygen is 6 here, 2 times 3, but aluminium becomes 4, so I adjust these 2 affected it, multiply by 2, come this side, and also change this value to 4. So it balances right away. There you can use multiplication. Let's now look at the last example here. I have sodium. Sodium is Na plus water, H2O, gives me sodium hydroxide plus hydrogen gas. Let's list the atom this side. This is Na, oxygen. Then I have on the left hand side and on the right hand side. On the left hand side I have 1 sodium, I have 1 oxygen and 2 hydrogen atoms. This way I have 1 oxygen, I have 1 sodium, 1 oxygen, then 3 hydrogen atoms. We see that sodium is balancing, oxygen is balancing, but hydrogen is not balancing. If we tried to use the same method of multiplying by 3 and by 2, we shall realize that it develops just complications in the expression. But it is much easier to add just one side to an even number that can be used this side, and we multiply and create that same number. So if this is 3, this is 3 because of a 2 on hydrogen and the 1 here. So by putting here 2, I make this 4. So it is easier to adjust this 2 to 4. So this is going to be, since this is 5, multiply by 2 here and transfer this 2 on hydrogen this way. So by putting a 2 hydrogens become 4. Hydrogens are 2 plus 2. 2 here plus 2 giving us 4. Let's check oxygen. Oxygen has become 2, so introduce a 2. So you'll have to multiply this side by 2. Already the 2 is there, so it's balancing. Sodium is 1. Sodium was affected. Sodiums are 2, so you need to adjust this side and transfer this 2. So the equation is balancing right away. Now you can either also list the atoms alongside the numbers, such as you'd list, can remove this and see another way of doing that. So you could list sodium here, hydrogen, oxygen, sodium, hydrogen, oxygen. This 1 sodium, 1 sodium, then you'd have 2 hydrogens, 1 oxygen, then here you have 3 hydrogen and 1 oxygen. So let's now adjust this number to 4 by putting a 2 there. So it affects sodium direct, multiply by 2, so come this side, multiply by 2 and transfer this to here. So hydrogens are 4, come here and adjust them by 2. So we transfer that 2 on hydrogen right away there. So oxygen atoms become 2 multiplied by 2. Here they are already 2 by observation from here. So the equation balances right away. Thank you for watching. See you in the next video for other topics to come.